Good morning, good afternoon, good evening to you wherever you are in time and space. My name is Alex Ball. I'm a research data librarian at the University of Bath and one of the co-chairs of the Metadata Interest Group. I'm delighted to welcome you to this session, Metadata for Reproducibility, Identifying and Addressing the Gaps, brought to you by the Reproducibility Metadata Task Group, which is a joint venture between the Metadata Interest Group and the Reproducibility Interest Group. Before we get going, I'd just like to remind you that this session is being recorded. So if you don't want to appear on the recording, please keep your camera off. And I'd like to extend an especially warm welcome to anyone here who is attending for the first time. Here we have a reminder of the 6 guiding principles that are at the heart of the RDA community and that underlie all of our activities and inform the conduct of this session. If you've not already done so, please do join the RDA as a personal member. It's free to do, and it gives you access to some additional resources from the RDA website. But more importantly than that, it gives you the opportunity to get stuck in and get involved. So once you are a member, and if you're not already, please do join either, but ideally both of the interest groups that are hosting this session, the Metadata Interest Group and Reproducibility Interest Group, and you can do that from the links on this slide. Another piece of housekeeping, please do load up the collaborative notes for this session and add your name to the attendees list. That really does help us a great deal. And them being collaborative notes, please do jot down your thoughts in those notes as we go through the session, and that will help to make sure that they don't get lost and that we can act on them in the future. You can get to those notes from the link on the slide. We've also put it in the Zoom chat. You can also get to it from the Hoover page. You go to the description for this session, you'll see a link that says read full agenda. If you go to that full agenda page, then the link to the session notes is one of the first links on that page. Also, I should mention that the link to the slides is also on that page. So if you want to follow along and extract any of the links, then you can do that from there. So the main purpose of this session is to let you know about some work that we've been doing within the reproducibility metadata task group. But before we get into the detail of that, I'd like to set the scene for you a little bit by introducing to you to the groups that are behind it, and also the reproducibility checklist working group, who have just started a piece of work that is relevant and complementary to the work that we've been doing in the task group. In the second half of the session, there will be a group discussion, which will be your opportunity to feed back on the work that we've done so far, and also to help shape and direct the progress of the work of the task group, so that we end up with an output that is maximally useful both to you and to the wider scientific community. But to start things off, I'd like to introduce you to the Metadata Interest Group. We are one of the longest running groups within RDA, having been established in 2013. The founding co-chairs were Rebecca Koskela and Keith Jeffrey. Keith Jeffrey sadly passed away earlier this year. He was a great advocate for the importance of metadata, both within the Research Data Alliance and also the many projects that he worked on. and the the wit and the wisdom and the insight and the energy that he brought to the activities he worked on will be sorely missed. The um, the metadata interest group was established to provide a forum for cross-domain discussions about the metadata that documents research data, to identify and promote metadata solutions to data management challenges, and to recommend how to improve the quality and interoperability of metadata so that the data described by it might better comply with the fair data principles. And coming out of those activities have been several notable outputs. One of the earliest ones was the RDA metadata principles and their use, which is a position paper that was jointly authored by the metadata interest group and some of the other core metadata groups from the early days of the RDA. And that sets out the case for the importance of metadata and also a vision for interoperability so that all the efforts that go into creating metadata, none of that will be wasted, and all of that metadata could be used for maximum benefit. One of the cornerstones of that vision was this idea of the recommended metadata element set. It's something we've developed up to a certain level. There is still some finishing off work to do with it. But the important thing to note about that is that it's not a new metadata scheme. It's not a new standard. It's more of a lens through which other metadata standards can be viewed. And in due course, that will feed into one of the other main outputs of the group, which was produced through a series of working groups, which is the RDA Metadata Standards Catalog. And that succeeds the earlier RDA Metadata Standards Directory, which was in turn a fork of the UK Digital Curation Centre's Disciplinary Metadata Catalogue. Rebecca and Keith retired from the group in 2024, and that's when we welcomed on two new co-chairs, Milan and Steve. And since then, we've been looking at ways in which we can take the work of the interest group forward. And I think you'll agree when we come to describe it that the work being done in this reproducibility metadata task group really does accord very well with the sets of activities that I've listed here on this slide, and is a very good direction for us to be going in. And at this point, I'd like now to hand you over to Lauren from the Reproducibility Interest Group.
Thanks, Alex. Hi, everybody. I'm Lauren Cadwallader. I work at the publisher PLOS in the UK. I'm one of the co-chairs of the Reproducibility Interest Group. And I'd just like to start with the kind of outlining our definition of what reproducibility is in this case, as you know, there are different definitions floating around, and it's always useful to kind of be on the same starting page. And so our group have kind of drawn from the Turing Way definition of reproducibility that you can see there on the slide on the left-hand side. So the same data, the same analysis, and because we're especially interested in computational reproducibility, the same computational methods as well. So that's what we're thinking about when we think about reproducibility, and kind of leaning into the Turing Way definition for those other terms about replicability, etc. Next slide, please, Alex. And so our interest group was first established way back in December 2014, and it was around for kind of almost 5 years before everything went quiet and it was on a bit of a hiatus. And along with Lee Moore, who will be speaking shortly, and Mandy Gooch, who's based in the US and North Carolina, and Tom Honeyman, who is in Australia, we kind of started up the reproducibility interest group again. We kind of resurrected it rework the charter to kind of bring it up to date with what we were aiming to do with the group. And our objectives for the group are really to form a kind of like a bridging or discussion group for various groups within RDA, but also looking kind of beyond the work that goes into RDA, into the wider kind of landscape, and really kind of bring the different people together and the different interests and provide a kind of holistic discussion forum that people can learn from each other, find out what's going on, and find common interests and kind of work on them together, bringing in those different perspectives, just as we're doing today. And so we've been at various plenaries in the last couple of years, like really establishing the group, finding out actually what's important to RDA members in terms of reproducibility and computational reproducibility, and like figuring out what the kind of most pressing needs are of the different groups in terms of that kind of bridging function. And so that's led us to establish a couple of different groups, one of which is this group today looking at metadata. The other one is the reproducibility checklist working group, which you'll hear about in a moment. And we've also, as a kind of foundation to that, done some work kind of gathering, or kind of doing that landscape analysis of all those different projects that are touching on reproducibility. And that's led us to produce one output, which you can see the link to there, the RDA and external reproducibility efforts, which is really trying to map the different groups, different outside groups, and the types of work they're doing in terms of reproducibility, whether that's something like a policy or a piece of infrastructure or kind of advocacy. So you can find that in the RDA Zenodo repository, and it was recently updated, or we sent it out for an update. I'm not sure if the updated version's made it into Zenodo yet. Well, Lemur's nodding, so I hope it has. And yeah, we're just kind of working on bringing those discussions and making sure that we're doing useful things for different RDA members in terms of computational reproducibility. And we are always looking for new members, and we recently lost one of our co-chairs, Claire Austin, had to step down. So we will be looking for a new co-chair in the coming kind of weeks and months. So if anyone is interested in reproducibility, please keep an eye out for messages about that. I think I'll leave it there and pass it over to Christian.
Yes, thank you very much, Lauren and Limor for the introduction as well. And so I'm Christian Paget. I'm based in Toulouse in France. I'm a research engineer. I'm involved in RDA since 2016. And I'm now a co-chair of the Reproducibility Checklist working group. The other co-chairs are Jiban, Leila, and Daniela. And so today I will briefly introduce the Reproducibility Checklist working group. And in this group, our goal is to help identify the minimum information needed to make research reproducible. So in practice, for example, determining whether research results can be reproduced is often difficult. For example, a researcher may find the dataset for a study, but the exact version of the code might be missing. The workflow may not be well documented, or the computational environment may not be described properly. So in any case, the issue is not that the work cannot be reproduced, but that the information needed to reproduce it is incomplete or difficult to identify. So the history of the group, this working group was approved by the RDA tab in November 2025, and it officially starts now. So it was created in response to discussions across communities, highlighting the need for a simple and practical way to assess the reproducibility readiness of research outputs. So the scope of the group is very important to define the scope of those working group, is to aim in developing a discipline agnostic reproducibility checklist. And the checklist what will be inside this checklist is to identify the key elements needed for reproducibility. So this includes data, software, workflows, documentation, and metadata. And of course, while reproducibility is often associated with computational sciences, our working group also explicitly includes non-computational disciplines, for example, social sciences and others. Though in those scientific fields, even if some analysis could be qualitative, many, all of them rely on statistical analysis or software tools, which means computational reproducibility is relevant across domains. So our current task, one of the first tasks we have to do is to establish a shared definition of reproducibility. So it's really share that with other the groups here, and it's we aim at a definition that can be agreed upon and disseminated across the scientific communities. In parallel, we want to map existing practices across disciplines and identify gaps in metadata and documentation that currently limit to reproducibility. So we do a kind of a review of what's out there and what could be useful for us. And so those activities will support the development of the reproducibility checklist. So to finish, of course, we are a very young working group, but we dive into the work right now because we have 18 months to deliver the output. And we also lost our chair, which was the same as the reproducibility IG. So we are looking for if someone else also wants to join as a co-chair. So we welcome participation also from researchers, infrastructure providers, metadata experts, or anyone interested in improving reproducibility practices. And if you are interested, you are welcome to join, even if you only want to watch what's going on, and maybe contribute later on, depending on your availability or interest. I think that joining enables you to follow what will be taking place. And also, if you want this to be relevant to your own scientific domains, it's the time to have a voice in our working group. So if reproducibility matters in your community, we'll be very happy to have you join the working group. So the goal is really is simple, but needs work to achieve. So it's really to make it easier to know whether research can actually be reproduced. So I have the link to join the working group there. And thank you very much.
Great. Thank you, Christian. Thank you, Alex, Lauren. I also want to acknowledge Patricia Feeney, who's on the call and helped us get our act together for the second half when we're going to open it up and have a little bit more of a conversation. But we did want to start off by just kind of telling you what we're up to, bringing you up to speed on our efforts. We have been trying to send out messages to the community to keep everyone aware of our what we're doing and ask for comments and input as we go. And we'll continue to do so. So thanks to everyone here. So my name is Limor Pierre. I'm based at Yale University. I'm one of the co-chairs of the Reproducibility Interest Group. And so I'm going to tell you a little bit about the Reproducibility Metadata Task Group, which is, as was mentioned, a joint effort of the Reproducibility Interest Group and the Metadata Interest Group, and really came out of the Birds of a Feather session that we had last spring on metadata for reproducibility, and the input that we got from the community that there is a lot of interest in this topic, and that some work to help clarify what is reproducibility metadata, or what is metadata for reproducibility, and where do we stand with that, and what might be recommendations along those lines. And so that's basically what we set up to do. Our big question was, how is reproducibility metadata expressed? Is there structured information, or is there machine actionable information that describes either the potential for computational reproducibility or the verification for computational reproducibility? And I'll talk a little bit more about that distinction, because that ended up being something fairly significant as we started to really dig in. So the goals of the group, we set ourselves a pretty brief timeline of 1 year, more or less, and we want to sort of identify and document any gaps regarding reproducibility in existing metadata schemas. As far as the schemas that do exist, what do they represent? How do they express reproducibility metadata? And then can we think of strategies for including metadata in schemas that don't have it currently, or can we think of an overall recommendation that will apply to those who want to include metadata or find it? So as I said, our timeline, we started in October. We opened it up with a call to the community to participate in the task group. And we thank everyone who's joined our effort so far. We'll have a little list coming of the folks who actively participated in contributing to our report. And there's been others who attended meetings, and we're very grateful for all the input. In November, we had a kickoff meeting. We began our work by sort of dividing up what people are going to, people self-assigned to metadata schemas that they're familiar with, and started to analyze them based on criteria that I'll explain shortly. And then we started to draft our report, and that's what we want to show you today, is a little bit about our draft report. We are presenting the preliminary. It's not even results. We're presenting the analysis that we did of the schemas so far, and the work that we have from now until October will include more synthesizing of what we find, what we see, obviously adding any missing pieces, and then coming up with some recommendations. So we can go to the next slide, I believe. So we went over this a little bit already. We had a call, which you can see if you wanted to take a look at the remit for the group. We started a collaborative document, which was a big Excel spreadsheet, and really invited folks to, wow, my phone never rings. This is my landline. I apologize about that. Hang on. People really had liberty to add. We structured the spreadsheet according to our criteria, but we let people take on any piece of information that they wanted and add. And from that spreadsheet, we copied into the report that we're sharing with you today. So when it came to selecting metadata schemas and standards, we were looking at a couple of things. Obviously, we're trying to be as complete as possible, and we will have an opportunity later for anyone to suggest more that we may have missed. But what we really wanted to think about is the perspective of both the creators and the users of the information, of the data, and the code and the computation. So from the perspective of the creators, can they even, is it possible to include reproducibility metadata in a given standard that they would like to use? By whatever means, is it possible? Do they have the elements? And from the perspective of the data consumer, the information consumer, can they pinpoint where the reproducibility metadata might have been supplied within a record? So is it easy and possible to find? So those were some of the things that we were trying to make sure that we include. I mentioned that we ended up understanding that there is really a typology when we're talking about reproducibility metadata, that we're talking about two things in a sense that are a little bit different. So one really has to do with the potential for computational reproducibility. So these would be metadata elements that that are necessary for someone to make the judgment when they see a piece of let's call it a replication package or any object. When they look at that data, code, etc., what do they need to know about these objects in order to understand if it could be computationally reproduced, if data and code could potentially be used for computational reproducibility. At the same time, we realize that there are ongoing efforts out there in the world where people are attempting already to computationally reproduce research and are trying to document those efforts. We're calling that verification of computational reproducibility. So these are efforts in the wild of organizations, people via software, via group efforts, via schemas, and in other ways who are engaged in active reproduction of research and are coming up with ways of documenting those efforts. And what we realize is that there's not a whole lot of standardization in terms of how they're doing that. So when we're talking about reproducibility metadata or describing reproducibility, we're talking about, elements that are needed to signify the potential for reproducibility. And in the next slide, you'll see in a minute what we mean by that. And then elements or ways of signifying that something has been reproduced. I hope I made that somewhat clear, but feel free to add questions in the notes in the chat, and we'll have an opportunity to, of course, to have a discussion about that. So when we're talking about the potential for computational reproducibility, we feel that at minimum, this is information that will allow someone to locate, access input data, locate, access, and execute a script or a workflow, and be able to locate and access the original output, have something to see what, the result of the computation so that it could be compared. So those are the main elements, the input data, the script or the workflow, and some sort of output. And so these would be elements that would describe those areas, those things. When it comes to verification of computational reproducibility, and we can have a discussion later on whether we also need those other elements in the potential, but just focusing on the verification attempt, the kinds of information we want to know includes who performed the verification, when they performed, because that could be significant. If a verification was successful 1 month after the publication of the result, will it also be successful 10 years after the publication, right? So we want to know when. The computational environment of the, where was the verification attempt conducted, in what environment, what were the requirements and constraints and so forth. What exactly was compared, whether it was the full paper, whether it was a particular piece of the work, like a table. We've seen efforts of verification where they break it down to claims. So it's literally at the level of an estimate. So we want to know what is it that's being reproduced. We want to know the target of the comparison. So what is the goal of the comparison here? When an attempt to verify computational reproducibility was made, how did they know if it was successful? Okay, so was the target to have a wholly identical result? Are there any other allowances for some difference from that original result? What were the, how is that defined? And then, of course, what were the results of the verification attempt? So is that documented anywhere? What were the results of the verification attempt? So those are the two kinds of things. So when we made our call to the community to suggest metadata schemas and verification efforts, and identify any elements that describe any of these things, we also asked folks to identify whether these elements were structured or dedicated. And really by structured, we're talking about something that is defined and contained versus something that is a little bit more free text. So is the information constrained in any way or not? And then we also asked on whether it was the element was dedicated. So here we're really looking at was the element an exact match to the question we're asking, or was it sort of maybe repurposed, or maybe was you'd have to do a little bit more work to understand if that's really what it's getting at. So we can go to the next slide. So the report, and we can add the link to the report. You have it also from the notes, and it's in the slides. Again, I want to emphasize one, our large number of contributors who've done a fantastic work in adding these standards and characterizing them and analyzing them and helping us think through what it is that we want to know. And then I also want to emphasize, of course, that as I said, this is a draft. And there's work to be done, the fun and interesting and challenging work of analyzing and producing some recommendations, which we hope to be able to present at the next plenary. Okay, so the next slide will give an overview of some of the existing standards. I'm going to hand it off to Alex, who's been sort of leading up this part of the report.
Yes, so as you can see, we've so far looked at 16 different standards. The 17th one there, the other standards, is where we have looked at a standard and didn't see anything there that would lead us to include it in a solution for representing reproducibility metadata. So that's really there. So to acknowledge the fact that we have looked at it and decided that there wasn't really enough to say about it. So I just like to give you a flavor of what analyzing one of these standards looks like in practice. And so this is an example of the core scientific metadata model, which was developed by STFC in the UK. That's the Science and Technologies Facilities Council. And it's the metadata standard that is used within their ICAT data catalog software that's aimed at large-scale research facilities. So looking at the potential for computational reproducibility, we're looking at those elements of what's the input data, what's the output data, what are the resources that you need to run the computation. There is a concept in CSMD of a job, which has a close semantic match to the idea of the computation that we're looking at. A data file that is input to the computation, that could be related to the job by this input data file predicate for a direct relationship, but you can also have an indirect relationship through a data set entity. there is a similar set of predicates for representing the output data as well. In terms of the computational resources, the software in the middle, there's the application that runs the job. The information that you can say within CSMD about the application is really quite limited to name and version. So that is most suitable for when the software in question is one that has a sort of formal release. It's not really suitable for modeling ad hoc workflows and scripts where you would perhaps need more information about how you would obtain and run it. And there are no native solutions within CSMD for talking about what prerequisites you need in place for the computation, for how you install the software, how you're supposed to execute it. But it's important to note that that's not the end of the story, because CSMD is based on RDF linked data principles, which means all of the properties of entities and the relationships between them are represented by subject, predicate, object triples. And the underlying philosophy of these linked data standards is that they are meant to concentrate on one thing and do it well, and to build on but not duplicate elements that exist in other similar standards. So gaps in one standard can be filled by another. And you'll see this repeated at various points throughout the report. And so to highlight this, I've put together this slide which sort of groups these standards together. And everything in the grey box with the RDF linked data and schema.org, they are all standards that work along these principles. And the key takeaway message to get from this is that, as well as looking at all of these standards individually, it's also important for us to look at them together as a collective, because of this principle of different standards concentrating on different things. It may well be the case that the optimal solution for representing the reproducibility metadata will actually involve a combination of several of these standards put together rather than concentrating on just one. And I'd like to hand back to Limor now to talk about the second part.
Thank you. Yeah, I just put a note, a little comment in our notes, because I was so impressed with your initiative to do that kind of Venn diagram, because I think it does advance us to start thinking more in analytical terms about what we're seeing in this space. And so I find it very, very helpful. And you'll see I tried to, to do something similar, maybe a little less successful, but we'll work on it. Okay, so these are the standards of or the existing efforts to do some sort of verification of computational reproducibility that we are aware of, efforts who are documenting these attempts to verify. And so we have about 14. I think there's two here that have an asterisk, number 7, DDI lifecycle, and Prov number 10. And I highlighted those just because they're also in the other list. So I think that's another area that we can kind of start to maybe look at how there's some crossover between, standards or schemas that are identifying key information, but then also are talking about an actual computational attempt and how to document that. So there may be, I know that there are more. This is not an exhaustive list, and so we would ask you later, but you can start thinking about this now, of what we might be missing. I'll just kind of, by way of overview, mention that there's There's scientific or scholarly associations here who kind of took it upon themselves to do verification of reproducible research and are then implementing practices and documentation within their publications and within their conferences. So I'll point out the ACM and the AEA as kind of leaders in that. They're organizations that are independent third parties like Cascade and CoCheck to some extent. There are we find this information in repositories sometimes and in registries or databases. And we find this information in dedicated software that is meant to help with these attempts to verify. So it's a little bit hard to kind of analyze these as one type of thing, like a metadata schema would be. But there you go. We still try. So to give you a flavor, if we can advance to the next one, we looked at CodeCheck. CodeCheck is a very interesting case study, and I think one of the more advanced in terms of having structured, dedicated, and potentially machine actionable information about a verification attempt. So CodeCheck, if you haven't heard about it, is a community-led initiative to help verify computational reproducibility in scientific research. So volunteers are code checkers, and they can run an author's code and try to reproduce results of a publication. And then they issue a code check certificate that document what was checked, who did the checking, what steps were taken. The certificate is then published with a DOI on Zenodo, OSF, and other things. And the information that's included in the certificate is also encoded in machine readable form. There's a configuration file that is stored with the reproduction materials or the certificate itself. And those appear in a registry. So all the information about this that I'm talking about now is in the report, and you could check it out. But the idea here is to encourage publishers and repositories to link to the certificate. So again, this is a third-party independent verification of the reproducibility of the results that is done by volunteers. So what is in the certificate? It captures most of the information we were interested in. Who verified the computational reproducibility? There's a field called Code Checker, which is the author of the report. There's an ORC ID associated with that. When the verification took place is expressed as the date of the check. It's also structured the comparison unit. So again, what was compared here when the verification was conducted. So there's a reference to the title of the paper. We know who the authors of the paper, a number or DOI, a persistent ID of some sort, referring to the paper, to the work that is being reproduced. In addition, there's a manifest of files. So there is a way to understand when the code checkers are creating the initial draft, you can produce a manifest and use those files. The result of the verification is expressed as a field called summary. Most of it is unstructured, but in there there is a indication of what happened as a result of the reproduction attempt. Verifiers are instructed to list. There's a place where they can list the output files and provide more information about the output of their computation in comparison with the original. Again, unique ID. There's a reference to the certificate and also a link to the publication. There is not really a way to capture, we're calling it platform, it's the computational environment, or, sort of the instructions, the very, very important instructions on the installation, the prerequisite, the computational environment, anything they did to prepare the data, to have to run the code, all of these sort of additional pieces of information that would be really important both to document the verification attempt, but also as information for future people who want to reproduce. The comparison target, again, the goal of the verification attempt, what were they verifying specifically? For example, is a result identical, or is it sufficiently similar? Is there an allowance for some deviation from an estimate, for example? That is expressed elsewhere and not in the certificate, but in some of the other materials that CodeCheck produces, where they say verification of computational results means checking that code generates the output it claims to create. So that maybe gives you a flavor of one of the more, and there are others. I'll point to some of the American Economic Association's materials and reports. There are some other efforts who are similar in trying to capture the information about the reproduction. Okay, so if we move to the next one, so this is one way to maybe think about these efforts, which is how is the documentation about the verification captured? What is the artifact, or what is produced, or what is the record of the information on the verification? And so in the case, for example, of the American Association for Computing Machinery, the ACM, they have a badge. There are several badges, and these badges might show up in the ACM digital library with a publication. You'll see like a little badge, and it'll tell you if the results were reproduced, or if there's various levels there. If the results if the underlying materials maybe are available. So it runs the gamut from these materials are available to they're accessible to they're informative. I can't remember all of the badges that they have, but the one we're interested in is the one that indicates that they were reproduced. There are efforts that have produced internal reports where they record all of these results, but they don't necessarily share that out. Or they're not necessarily made public. I think in some cases they could be public. There are efforts where they really focus more on the guidelines, and in light of the conversation that or the comment that Alex made about some standards that were looked at but decided earlier and decided in the other group that they were not exactly covering what we are looking for, I'm wondering if some of the publisher guidelines are more really policy oriented and a little less practical or implemented, and we need to look at the implementation of these guidelines. That's a comment we can discuss. Another group might be these public reports that are being shared. Sometimes the information will show up in repository metadata. So for example, obviously DDI, Lifecycle, and Prov are not repositories, but they are providing the metadata for some repositories, and you might see the information we're interested in the repositories who are using these standards. There are databases, like I mentioned. I4R is the Institute for Replications, and they do these massive replication games and marathons, hackathons, and they put everything in a database. You could look at results. And then we have some attempts at creating software and having the software encode some of these fields. So that is one way we can look at it. I think there are potentially other ways. I'm not sure this is the most useful, but that was just a first pass. Okay, so now we come to the fun part where we're gonna ask you a few questions, and then we hope to kind of open it up and have a little bit more of a discussion. So with that, I'll hand it back to Lauren and Patricia to take it away.
Thanks, Limor. Yeah, hi everyone. If you could just join menti.com with that code. Alex, I'm gonna switch to my screen if that's all right. There we go. Share screen. then hopefully you can see the Menti poll here. If you're still joining, the kind of code you need is over here. Thank you for all the thumbs up. So the first question is a bit of an icebreaker. Have you ever tried making your own data or computation reproducible? Nice to see that many of you have. It's often one of those things, I think, until you try it, you sometimes don't realize how difficult it can be. I'll just leave it up for a few more minutes, or a minute or two, whilst we get more respondents joining. Or perhaps you're not producing your own data or computations to reproduce, but it's perhaps a good thought exercise how you might do that. So we've got more people are joining, which is always great. I think we've got about 30 odd people on the call. So just to give you a few more moments. But yeah, nice to see so many of you have. Those of you who haven't, why not give it a go? It's always good to do. Right, let's move into our proper first question. Hopefully you can see the new question. What else can we include in the metadata? So it's thinking about both the potential for reproducibility and the verification of reproducibility that Lee Moore and Alex were presenting. And they showed the kind of elements that we've been looking for in those metadata schema, the kind of who, what, when that Lee Moore was talking about with the verification attempts, for example. Are there any other key things that you think we should be capturing in metadata about either the potential for reproducibility or the verification of a reproducibility? I think, and Lee or Alex, if you've got anything else you specifically want to ask this question, please just unmute.
I'll just mention that I think here the work of the checklist group would potentially come in very handy because we might learn more things from the checklist. And the other thing that I'm thinking about is that in a lot of disciplines, or in some disciplines now, there are reporting requirements. I'm thinking, for example, in medical, biomedical, the consort protocol and things like that. So I'm wondering if there are elements from reporting requirements that might be used.
Yeah, precisely what you said there. Someone's suggested protocols associated as one requirement. I'll let these come in for a little bit. So we've got kind of expanding it to include more of the Turing-Way matrix. So that kind of little diagram we showed right at the beginning with the difference between reproducibility and replicability, whether it's the same data, same analysis, or different data, same analysis, in various combinations. Yeah, that would be interesting, and I guess would open up a whole next level of metadata you might need to capture if you're using different data or different analyses, depending on your combination of things. Yeah, and I think from the discipline's reporting requirements, I think we've tried to be fairly discipline agnostic and quite inclusive so far with the schema. I don't know if you guys have noticed anything kind of discipline related as you've been going through them. Now, this isn't I think this one here, potential for reproducibility, the type of output that can be reproduced, whether it's a table, a number, or a graph. That's also quite interesting because often, like from a publisher's perspective where I work, we talk about when we're trying to decide what counts in, say, a code sharing policy, we're going, well, do you need to share all the code needed to reproduce a figure versus do the analysis? So I think, knowing the potential for how much of an article, for example, could be reproduced is quite interesting from my perspective.
And I could tell from my perspective as a small organization that is actually doing the verification that we, whether the results are in the main text or in the supplementary material or appendices, that that makes a big difference because as we all know, appendices have gotten very long, very, very long. All the extra analyses and the robustness checks and everything else is in the appendices. And do we need to reproduce all of that? So just being able to pinpoint what it is that we want to reproduce. Yeah.
Mhm. Yeah, these are all great. Alex, is there anything you wanted to pick out in particular, any of these?
No, I was just replying to some of the comments in the chat.
Oh, great. Sorry, I can't see the chat, so appreciate that. Yeah, so I think some of these are great, thinking about expanding the scope, maybe, and thinking about what existing things we can lean into for that, and whether that's in terms of disciplines or the types of reproduction, uh, or the amount of details that we go into. I think they're all really great suggestions. I'm going to move us on to the next question, if that's all right with everyone. Great. And so it's a thought about what metadata standards and specifications are we missing. So hopefully you've got a link to the collaborative notes and you can find the slides from there where we had a list presented of all the different standards and kind of schemes we've been looking at so far. But was anyone sat there thinking, oh my God, I can't believe you've missed this? Please let us know what that might be.
I don't know if you want to flash the list that we have or folks can go in the slides too and see there. The next slide just lists all of the ones that we looked into.
Yeah, and thank you to whoever's made the comment that they're surprised and impressed with the work we've done. See so many. I think I was also quite surprised at how many there were as we were kind of as this list was created.
I will just mention, because it hasn't made its way onto the slides, that there were a couple of other ones that we had identified to look at, but we didn't quite manage to get them ready in time. And one of those was Serif, and another one was protocols.io. So they will be making their way into the report at some point. And I noticed someone had left some comments in the collaborative notes before the session to point us in the direction of the ESIP Federation scienceonschema.org recommendations, and they had there are some points there that we will certainly want to take a look at, and one of them was an extension to Prov1 to Prov that Data1 produced, called Prov1. It's still listed as being in draft, but I think that is also something that we will take a look at. So thank you to whoever added that into the notes.
Yeah, and thanks for the suggestions coming in. I think relevant workflow tools and kind of provenance tracking systems are a really interesting suggestion. I think especially as research groups are kind of more conscious of sharing openly and employing tools to kind of automatically generate metadata for them. I think that will be an increasing thing. Yeah, I got some good things to think about there, Lemur. Yeah, and I think AI agents and models and how they get taken into account is always going to be a emerging question and problem for these things.
Yes, and thank you for the reminder to connect with the Fair for Machine Learning, because definitely in our orbit, and there are several other RDA groups that are doing work that that could have an impact on this and inform this effort for sure.
Mhm. Okay, should we move to the next question? Think that. And please, like if I move on and you have other ideas, you can add them to the collaborative notes anytime. And now thinking about the kind of draft report that we've shared today, the thought was that this would be written up and shared around. But one of the questions, of course, is like who are we trying to target with these recommendations or these kind of insights into the metadata for reproducibility? Like if we come up with recommendations that perhaps X, Y, and Z should be included in the metadata, who do we really want to kind of look at this document and kind of think about the insights that we're drawing from it? And of course, I guess we might have multiple different audience members, so we might have to change the report or edit it to include things that speak to different people. So we've got lots of specialists in here, developers, data stewards, repositories. So this is kind of infrastructure folks. And then I guess what I think of as enablers, right? The data stewards and the librarians. And then and the repository curators. We've got publishers in there as well. And I guess researchers in terms of the people who are sharing these outputs, right? And so might need to include the metadata in terms of the potential for reproducibility. Is there anything in there surprising either of you, Lima or Alex?
No, I think this is great. I think this is great. I'm just trying to think through because researchers are they're in a different place. You can ask them to provide information, but they will usually do the minimum that they have to do. So I guess what I'm saying is with them, if the recommendation is aimed at researchers, then the next thing to recommend would be a really easy way for them to do to add metadata.
Yeah, definitely. And I guess these different audience types can help us think about, the next steps for this task force and actually what the final outputs look like.
Right.
I'm going to reveal my ignorance here, but I don't know what OSPOs are. OSPOs.
I was going to ask about that.
Whoever put it in can say. I think it's the Office for it's open software, university offices, but please correct me if I'm wrong. Open source project office. Yes, 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 yes. Thank you, Amy. And Linda, yes. So some universities have set up open science, open source. I think it's mostly about software, open source software, project offices to encourage those efforts on their campus. Interesting.
Thank you. Okay, I'll move us on to, I think, the final question. And that's again about recommendations and what sort would you find most useful? So we've got kind of three options and then another option. And if you feel strongly about another option, please tell us what that option is. I think you might have to do that in the Zoom chat rather than Menti. I can't see the participant view, so I can't remember how this is set up.
No, Menti has the choices. I think you have to check the ones you
Okay.
want to choose. Yeah.
Yeah. So if you're checking another option, we'd love to know what that is. Showing responses. There we go. So getting most votes for a single common approach. That's used in addition to current practices. And then ranked, verified, reproducible badging system is also quite popular.
Mm-hmm.
Oh, it's getting increasingly popular. And I guess the two things can work in parallel because we're talking about both the potential for reproducibility and the verification of reproducibility. So shall I end it there? I believe that's the end of the presentation. Perfect. So I'll stop sharing. Do we have time for a bit of discussion? I don't know if anything's come up in the chat.
We wanted to open it up. I can't see the notes. I can take a look. I don't know if there's some comments there, but we want to hear from you in the audience here, our community, about you're thinking about and reactions to the report and the work that was done, and also in the context of the questions that came up, if that has brought up any other thoughts that you think would help direct this effort in the right way, or any other obstacles or challenges that you think we might encounter. So I think you can feel free to either add a question or comment in the chat, or just unmute yourself and feel free to jump in. So Tristan comment in the chat, that's a great point. Another option may be covered by the existing options, separate researcher-oriented recommendations for schemas that successfully encode reproducibility that they can adopt, and schema developer-oriented recommendations in terms of how they can design their schema to successfully encode reproducibility information. for the schema developer or implementers, and then for the research oriented, having two sets of recommendations. That's certainly something we can consider and could help with that issue of how do we engage with our recommendations.
A bit further up, Mark to Horst left a message in the chat asking, is it better for scientists to include standards for analysis included in standards for reporting the acquired data instead of having two standards to reference? Am I splitting hairs? Did you want to unmute and have a talk about this point?
Oh, there I am. Hi, everyone. Yeah, so coming admittedly, I confess, from an instrumentalist point of view, not a data scientist, forgive me if I miss something that the rest of you take as obvious, but when I talk to faculty here on campus, and I'm in the chemistry department, about reporting data, the thought of all the data they have, say if they've run a series of reactions and they've used instruments to analyze the products and the kinetics, right, how the reaction happens. There could be dozens of techniques, different computer programs they use to get numbers out of their data, yeah, that other chemists care about. Then having to go through and say, well, what metadata do I need to include for the acquired data and for how I analyzed it? Forget about pure computational things that they have to report. Now, as I understand it, if I have the words right, they have different schemas they need to look at. And that has to be applied to different types of data, which in their mind is different, right? They're different worlds. If they do mass spectrometry, sorry, that's different than X-ray crystallography, which is different than electronic calculations for molecular structure, for example. Does that help, or am I just way off in left field?
No, I think one of the things that we're wrestling with is about the extent to which you can encode the reproducibility metadata in the schemas that you already have, or the extent to which you might need a separate scheme that's more dedicated to reproducibility metadata. And one of the things that comes out from doing our analysis is finding out that some schemas are more able to express this kind of information than others. Some are very focused specifically on the data, not on the process by which it was created or that it might subsequently be processed. And so if you're in a domain where you have those kinds of standards, then you're probably going to need metadata that's about a different object, which is why we were looking at things like a metadata scheme for machine action or data management plans, which will give a kind of higher level view of the research operation and therefore might be a better home for this kind of metadata.
I would like to maybe try to respond to Dorian for the comment in the chat and not taking it as a critique at all. Great points that you're raising there. And I think there are really two. One is about more qualitative research, and the other one is about what do badges sort of signify. I'll just try to respond to that, but I invite anyone else to think about this too. So with qualitative research, maybe less number and computation based and more interpretive. Um, the short answer is that we are talking about computational reproducibility, and so there is a question of whether it's in scope or not. But I will say that even the more interpretive disciplines use computers these days, um, and track things. I'm thinking of software like in Vivo, for example. There are some parameters and some information that can be shared about the computation the use of the software that could be relevant for reproducibility. Obviously, we are talking about something a little bit different. But as to the question about badges, I think that's a really great question, and it's kind of beyond what, it's badges in general, in terms of like assigning a greater value to the research itself, because it has a badge, rather than the badge just indicating that something was reproduced. So it's, a badge of honor, in a way. And so personally, my bias is always toward having more information and having a report than just having some like quick signal. But I also understand that there's a need for that, especially, if you're trying to indicate quickly that something was reproduced. But I would always encourage users or people who are interested in the research to see what exactly was reproduced, and to like really get all the information that would be supported by metadata. So that they can understand what was reproduced, and make a determination about the quality that way, and not just based on a badge. Right. And digital humanities, I don't know that we have that expertise among our group specifically, but I do know that the digital humanities do a lot of computation, and that is a very interesting and growing area. So yes, data may not be tabular. It's not necessarily statistics in the way that we think about it, but the issues are similar issues. There are constraints on all of these things, right? Like it's never going to be the same for all the disciplines. Even if we're thinking of social science data, or social science research, there are giant efforts to make it more reproducible in political science and economics. But what if the data is sensitive data that can't be shared? How do we talk about reproducibility when other people cannot access the data? So we have to kind of take into account the limitations that exist there. Yeah, so other questions? Let me ask a question of the group. Are there RDA groups that you are involved with or that you are aware of that are doing work? We talked about FAIR for machine learning. Um, there are groups in the orbit of the metadata IG, and there are groups in the orbit of the reproducibility IG. But if one jumps out at you that you think that they're doing very work that's very related that we should be aware of. Thank you. Thank you, Tristan.
So a pretty tangential relationship, I would say, but I'm part of the Fair Mappings working group, and thinking about mappings as it relates to this work. It kind of looking at your case studies, particularly the one that was presented. I forget which schema, but on the topic of potential reproducibility. I think the work kind of seemed like d- developing a schema ahead of time. So things like input data, output data, and computational and the computational workflows that were used. And so in publishing this work, it might be worthwhile thinking about how you document which fields were matched to which of your kind of conceptual fields in the schema, um, and how that mapping is documented. I get not overly connected to the target of this group, but I think an interesting connection.
Thank you. There's a comment in the chat. There's a BOF session on Monday, Bridging Fair, Enabling Resources, Implementation Profiles, and Cross-Domain Interoperability. Could be for the output of this group. Yeah, so that's a good suggestion. Thank you. We can definitely look into their work there. Super. Thank you for the link. Okay, Alex, Lauren, any other thoughts for you or questions for the group?
I was just going to say thank you for everyone's input into the session. It's been useful to hear that the work done so far is not made people kind of hold their head in their hands with a kind of oh my God, what have they been doing? But it seems to be well received. So thank you.
Just responding to the point you made, Lee, more about some data being having to be protected because of the sensitivities. I think that does perhaps underlie the importance and value of these badging systems and other bits of metadata that describe the results of reproduction attempts, because that can be a way for somebody who has access to the data in order to communicate value and transparency about the computation that others may not be able to have access to, and therefore be able to communicate that more widely and to demonstrate the value of the research that's been done.
That is a great point, Alex. Thank you. You know, if people are saying, I don't know if this is reproducible because nobody can access this data, so I just don't know. But then someone can say, well, I did have access and I was able to reproduce, and here is the the evidence and the information about that. And that definitely increases credibility. And after. Maybe it's obvious or we don't say it enough, but this whole effort is really in the service of the credibility of the scientific enterprise, the enhancing trust and transparency and accountability. So all of these terms, this is what why we're doing all of these things. Yeah, thank you. Great point. I guess I'll mention that we are going to elicit and ask for more community feedback as we continue to work on our report. Will be finalizing and doing some analysis. I invite everyone to let us know if you're interested in helping and having a more active role. If you'd like to contribute to the report, please let us know, Alex, myself, Lauren, and we'll make sure that we are promoting and informing the group on our next meetings and on our progress, so that you'll have plenty of opportunity to let us know your thoughts. And yeah, we're looking forward to having something to share with the community in October. It's very exciting for us, and we're very grateful for the contribution so far, even in just helping us shape the work and raising this to the level of prominence for both these interest groups to kind of take it on. So yeah, great thank you to the co-chairs of the metadata interest group and to my co-chairs in reproducibility and to everyone who's participated in the reproducibility metadata task group. Yeah. All right. Please put your name in the note in the shared notes. I think if you are interested, or you can find our information via the RDA website and email, contact us directly if you'd like to do it that way. My email, I know, and I believe Lauren and Alex are on the notes as well. Thank you. Thank you all so much. Thank you, Christian, and thank you, Patricia. Ramiro, I know you're on the call. Thanks to everyone who contributed. Really appreciate it.